Hey guys, it's time to take a look at going the other way with our binary conversion. Last time we converted decimal numbers into binary, and this time we're going to, we converted binary numbers into decimal, excuse me. This time we're going to convert decimal numbers into binary. So let's go ahead and go to the desktop. All right, so here we are. We're looking at our whiteboard again, and the number that we're going to convert is the number 102. That is a decimal number, it's a regular number, and we want to know what that would be in binary. Now, when we were going the other way, we multiplied and added. Coming back this way, we're going to subtract. So what we have to do is, first of all, find one of the places up here. Now, step number one for both of these processes will be to write down the places for binary. 1, 2, 4, 8, 16, 32, 64, 128. Those are the decimal places, or the number places for a binary system, just like 1, 10, 100, 1,000, and so on for a decimal system. So we're going to write down the numbers. Step 2, we need to find a number that is less than 102. We can't use 128 because if we did, that would mean there'd have to be a 128 place inside the number 102, and that won't work because 102 is smaller than 128. So we know right away that we can put a 0 under 128 because that one won't work. We know our first digit's going to be 0. It won't require that place. But can we take 64 out of 102? That we can do. We know that 64 is going to be divisible or removable from 102. So the first thing we do, we put a number 1 under 64, and then we subtract 64 from 102. And that leaves us with 38. So we've taken 64 out. Now we've got 38 more to account for. And so what we need to do, once again, is find a number that's just less than 38. Can we do that with 32? Yes, we can. Because 32 is just less, there we go. 32 is just less than 38. So once again, we subtract. Remember, we're going exactly the opposite of what we did converting the other way. We're subtracting the numbers out. So we take 38, we subtract 32, and that leaves us with 6. So we have 6 more to account for. Can we take 16 out of 6? Sadly, we cannot. 16 is too big. 6 isn't big enough. Can we take 8 out of 6? Also, that would be a negative. We cannot do that. Can we take 4 out of 6? Yes, we can. So, in fact, we can take 4 out of 6. We subtract that, and that leaves us with 2. We can subtract 4 out of 6. Now we have 2 left to account with. So, can we take 2 out of 2? Yes, we can. It's possible to do it and have a 0. You just can't have a negative number here. So, if we take 2 out of 2, that gives us a 0, and we don't have to worry about the ones place because we can always put a 0 under there. So, the number in binary that represents the decimal number 102 is 1100110. That number in binary is the same number as 102 in decimal. So that should be a pretty good starter on how to convert from decimal to binary. You just have to find the place up here to start with that's just smaller than your starting number. You put a 1 under that, anything in front gets a 0. You subtract, you take whatever's left, and you find the next number that's just smaller. You put a 1 under that. Anything between the two gets a 0, and you continue that process until you get all the way to 0. It will always come out evenly at 0. You're either gonna get a 1 here, or you're gonna get a 1 here. So it's always gonna come out evenly at 0, and that's how you will determine, or that's how you'll convert rather, from a decimal number to binary. Guys, I hope this helped. If you have any questions, please contact me. I've already got the other one up, and I'll have this one up shortly, and hopefully that will give you a leg up when we start doing subnetting. Subnetting is all about converting binary to decimal and decimal back to binary and so on. So if you have any questions, please let me know. I'll see you guys in class.